Hey guys, this is Excellent the Math Doctor and welcome to my YouTube channel. So guys, today we're gonna be looking at a very interesting topic from grade 11 which is called rationalizing denominators. Okay, so in terms of rationalizing denominators, guys, in simple terms, it just means that you are going to look at the given denominator, whatever denominator that you've been given, and then you're going to change it to what? To a rational number. So in terms of rationalizing denominators, it means that at the end of the day, you must make sure that your denominator is rational. Okay, so if you can look at the denominator that we're given here, guys, we have the square root of 3. Okay, so the square root of 3, guys, is what we call a surd. Okay, what is a surd? A surd is just simply the root of a number that is going to give you an irrational answer. So, in other words, a surd is just an irrational number in simple terms. Because if you look at the square root of 3, that is going to give us what? An irrational answer. An irrational answer. So, there are a lot of examples that you can use. For example, the square root of 5, the square root of 2, those are all surds and they are all irrational. Okay, so we can identify that okay, the denominator is irrational because of the surd. Now we need to figure out how we can make it rational. Okay, so the first step is gonna go like this. I'm gonna rewrite the expression here. So I'm gonna write equal to, then I write 5 minus the square root of 2, right? Then over 2 the square root of 3. Another thing that is very important to note, guys, you need to check how many terms your denominator has. Okay, so if you can look at the denominator that we're given here, this is only one term, it's a single term. Okay, so how do we know that it's a single term? Is because the bases are not separated by a plus sign or a minus sign. For example, guys, if you look at the numerator, our numerator is 5 minus the square root of 2. This one, it contains what? It contains two terms. Why? Because we can see that the bases are separated by a minus sign. So, in other words, what this means is that terms are only separated by a plus or a minus sign. If there is no plus or minus sign in between the bases, it means that that will only will be classified as one term. That's why 2 the square root of 3 is what? It's one term. But if there was a minus sign or a plus sign maybe in between the 2 and the square root of 3, we were going to say that we have two terms. Okay, I hope that makes sense. Then the next step is gonna go like this, guys. If we have only one term in the denominator, all we have to do, guys, is just to take the denominator, the term in the denominator, and multiply both the numerator and the denominator by that term. So what I mean is that you are going to times the numerator by 2 the square root of 3, and you also times the denominator by what? By 2 the square root of 3. So you take the term in the denominator, you multiply both the numerator and the denominator of the fraction by what? By that term. Okay, so this is the next step. Then from here, this is what you're gonna do. You just multiply everything out. Okay, so you can write it like this. I'm gonna write equal to, then let me write 2 the square root of 3 here, right? And then I'm gonna put 5 minus the square root of 2 in brackets next to 2 the square root of 3. Oh, I just realized that I wrote square root 5. Okay, it's supposed to be 3 here, just like we have here. Okay, so it's 5 minus the square root of 2 in brackets like this, right? So this is just to show that we need to take the 2 square root of 3 and multiply it by both of the terms that are inside of the brackets. Okay, then we have over, in the denominator we are also going to be multiplying the terms in the denominator, so we are going to times 2 square root 3 by 2 square root 3. Okay, you just have to do this step by step, ne? So first you can just start by multiplying the ones that are outside of the root. And another thing, guys, never multiply a number that is inside of a root by a number that is outside of a root. So when you multiply numbers, you must make sure, okay, the numbers that I'm multiplying right now, they are both outside of the root or they are both inside of the root. That's the only way you can multiply. So in this case, it means that we can start by multiplying 2 times 2 because both of them are outside of the root. And 2 times 2 is just going to give us a 4. Okay. Then here we take square root 3, we times it by what? By square root 3. Square root 3 times square root of 3 can just be expressed as square root of 3 squared, okay? Because it's two of them. You have square root of 3 times 2. Or let me not say times 2, it's square root of 3 times square root of 3, so it's square root of 3 multiplied by itself. Yeah, it's better to put it like that. It's not times 2, it's multiplied by itself. So when it's multiplied by itself like this twice, then it means that you can just square it. You can just write square root of 3 and then you square it just like that to show that you are multiplying it twice by itself. Okay, then from here we go into our next step, which is gonna go in this way. I'm gonna write equal to, then I'm gonna first deal with the denominator to the numerator, whereby I'm gonna take 2 the square root of 3 in front of the brackets here. I multiplied by what? By both of the terms that are inside of the brackets. So first we start by saying 2 the square root of 3 times 5, right? So you can just multiply 2 times 5 since they are both outside of the root, okay? So 2 times 5, it will give us what? It will give us 10. And then you just write the 2, you just write the square root of 3 next to the 10, okay? So what you times is what? Is both of the numbers that are outside of the root. So don't try to times 5 by 3. Why? Because 3 is in a root, 5 is not in a root. That's why I can only times the 5 by the 2 because both of them are outside of the root. Okay, so 5 times 2 is 10. So we're going to have 10 square root 3. Then we take 2 square root of 3. We also times it by what? By negative the square root of 2 in the brackets. So, okay. First of all, guys, 2 the square root of 3, right? Outside of the brackets, they never put a sign in front. So if there is no sign in front of the 2 square root 3, it means that the sign is positive, okay? We don't have a sign in front of it. It means that the sign is supposed to be a plus sign. So the reason why I'm notifying you of that sign is because the square root of 2 has a negative sign in front of it. So we're gonna start by multiplying the signs first, okay? So we take the positive sign from 2 the square root of 3, we times it by the negative sign of the square root of 2. So positive times negative, the signs are different, guys. So as long as the signs are different, it's gonna give you a negative sign. So whenever you're multiplying signs that are not the same, you're gonna end up with what? With a negative sign. Then from here, I'm gonna write 2 in front in the front of square root of 3 here, right? We have 2 in front of square root of 3, so I'm just gonna write it down here, right? Then what I'm gonna need to multiply now is what? It's 3 and 2 because both of them are inside of a root, so I can multiply them by each other. But the 2 in front of square root 3 here, I'm just going to write it as it is. I cannot times it by the 2 that is inside of the root because 2 is not inside of the root here in front of square root of 3, but the other 2 is inside of the root. So the 2 in front of square root of 3, I just write it as it is since it's not in a root. I cannot times it with the one that is in a root. Okay? So this is how it goes. I write down the 2 in front of square root of 3. I write it down and then I times the 3 and the 2 that are inside of the roots. So I'm going to write a root like this. Then I say 3 times 2, which is going to give us a 6. Right, as simple as that. Then we go to our denominator, guys. In the denominator, first of all, we have 4, right? Let me write it down. Then next we have the square root of 3 squared. Okay, guys, another important thing that you need to note, whenever you have a square root like this, and the square root is raised to an exponent of 2, what you need to know is that an exponent of 2, which is a squared, will automatically cancel out the square root. So in other words, what I mean is that a square root and a squared, or a square root and an exponent of 2, they eliminate each other, they cancel each other out. So So basically, if they get cancelled in our expression here, it means that what we're gonna be left with is the 3 that was inside of the root. So I just write 3 like this. So a square root and a squared, they what? They cancel each other out when we put it in simple terms. Okay. Then next we just have to times 4 by 3, right? So it will go like this. I'm gonna write equal to, then we have 10 the square root of 3 minus 2 the square root of 6. Okay, then we write over what? Over 4 times 3. 4 times 3 is 12, so it's gonna be over 12. Uh-huh. Then guys, from here, we're not done yet. There's still one last step that we need to do, okay? So that step, let's just start by separating the numerators, ne? How do we do that? I'm gonna take the first numerator, which is 10, the square root of 3, okay? Then I put it over what? I put it over our denominator of 12. Then I say minus, then we go to the next term in the numerator, which is 2 the square root of 6. Then I also put it over the denominator of 12. So both of them, they take 12, 12. They share the denominator of 12, right? Both of the numerators. Okay. So when you separate them like this, what I want us to do now is to divide. How are we going to divide, guys? We just have to look for what we call a common factor, or the highest common factor. For example, if we have 10 over 12 like this, right? 10 and 12 have a common factor, okay? Meaning that they can be simplified. And I'm focusing on 10 and 12. I want to divide both of them by the common factor because they are both outside of the root. So I'm focusing on the ones that are outside of the root. So square root of 3, we just leave it as it is. So for 10 over 12, we're going to divide by the common factor that enters into 10 and 12 without leaving a remainder. And that number is what? Is just 2. So meaning that I can say 10 divided by 2, which is going to give me 5. So I'm going to have 5 the square root of 3. Then over what? I also take the 12, I divide it by 2 as well. 12 divided by 2 will just give me a 6, like this. You see how we do it? So you look for the common factor, the highest common factor of 10 and 12, meaning that you're supposed to look for the highest number that can enter into both 10 and 12 without leaving a remainder, and that number is 2. So you divide 10 and 12 each by 2. Then for the next term, we have 2 over 12, right? Remember, I said that we're not going to be minding the number inside of the root. We just leave it as it is. We are focusing on the ones that are outside of the root. So here we have 12 over 2. 12 over, wait, not 12 over 2, the other way around, 2 over 12. Okay, so if we have 2 over 12 like this, the common factor, or the highest common factor of these two numbers, will just be 2 as well, right? Because I can divide 2 by 2 and 12 by 2, and it won't leave any remainder. So first of all, 12 divided by 2, guys, let's start with the 2 on top. 2 divided by 2 is what? It's 1, okay? But I don't necessarily have to write 1 square root 6. If the 1 has another number next to it, like square root 6 like this, I really don't have to put a 1 in front. Remember, if you have a coefficient of 1, coefficient meaning that the number in front of the variable or the root, like that, right? If the number in front of the root like this, it's 1, the 1 is not necessary that we should write it, okay? So if it's a 1, we can just what? We can just drop it, or we can just make it silent, if I can put it like that. So you just write square root of 6 only. The reason why it's not necessary to write a 1 in front is because if I say 1 times square root of 6, it will just be square root of 6, because 1 multiplied by any number, it will just be what? It will just be that number. If I say 1 times 2, it will just be 2. If I say 1 times 5, it will just be 5. You understand? So that's why I really don't have to put the 1 in front of the square root of 6. Because if I say 1 times square root of 6, it will just be square root of 6. So it's not necessary for me to put the 1. So I just write square root of 6 there. Then in the denominator, I divide the 12 by 2 as well. So 12, meaning you must divide by the same number in the numerator and the denominator. So 12 divided by 2, it will give us a 6 again, like this. Then basically, I just wanted to separate the two terms so that I can simplify each of them individually. That way it makes things, easier if you do it bit by bit, if you don't try to do everything all at once, if you just separate them and try to do each one individually, it makes things much more easier, breaks them down for you in a very smooth way. Okay, so from here, the next step, basically, the next step, we are done. The next step will just be to put all the numerators over the same denominator. Why? Because the denominator is the same. It's 6 6, right? So I can just write one denominator of 6, right? And I write both the numerators on top of the same 6. So I write 5 square root 3 minus square root 6. Then you are done, guys. This is very simple. This is your answer. If you try to put the answer on your calculator, your calculator will write the negative square root of 6 first, and then it will put plus 5 square root of 3 after. But it's simply the same thing. Whether you put negative the square root of 6 first, or you put it at the end, or whether you put 5 the square root of 3 first, it doesn't really matter the order, as long as each of them has the correct sign. Okay, see, square root of 6 is negative, and 5 the square root of 3 is positive. So whether you put which one first, that one is not really an important factor. Then you write it over a 6, then you're done. This is a very simple and straightforward topic, guys, and I really hope that you enjoyed the lesson. You were able to learn a lot from it, right? Okay, guys, thank you so much for your time. And if you like my videos and you want to make sure that you get notified next time I post another maths video, make sure to subscribe to my channel and to like as well as to share my video. Okay, and another thing, guys, which is very very important, if you are interested in joining my maths classes from the Maths Doctor Academy, all you have to do is just to contact the number on the screen, which is 081 703 1197. And as you call this number, you'll be notified of two packages that are available. The first one being the package whereby you attend once per week. So if you attend once per week, it means that in a month it will be 4 times a month, and that one is 300 rands per month, right? Then we have the second package whereby you attend from Monday to Thursday. This is the school version because you are attending a lot more than you would normally attend in terms of extra classes, right? So it's from Monday to Thursday, which is 4 times a week, meaning that in a month you're going to be attending 16 times a month. And this package is only 650 rands per month. So all you have to do is just contact that number and choose the package that is most preferable for you. Okay, basically that's all for today's lesson, guys. I really hope you enjoyed. Then I hope to see you again in our next maths class. Thank you so much, guys. Bye.